In this example, we have calcium, which is an alkaline earth metal located in group 2 over here. Calcium has two valence electrons, the one that you have over here, and this pictures that you have here is the electron dot diagram, in which you're going to represent the element symbol with the valence electrons. Okay, calcium is in group 2, two valence electrons, and those electrons are the ones that are ready for bonding. Then you have oxygen that is in group 16 with 6 valence electrons, 1, 2, 3, 4, 5, 6. Oxygen doesn't have any electrons on the last shell. So what's going to happen when they are forming an ionic compound? Calcium is going to reach that chemical stability by losing the 2 electrons. It's going to lose these 2 electrons. And when calcium is losing these 2 electrons, calcium become a positive ion, which is a cation. Now, how many electrons calcium is going to lose? 1 and 2. Either 2 is over here. Now, the numbers that you have over here, they are called the oxidation numbers. And what are the oxidation numbers? The oxidation numbers are the amount of electrons gain or lose during gain or lost during an ionic bonding. Okay, now that's the metal. For the non-metal, the 2 electrons that calcium was losing, oxygen is gonna gain them, and that way, okay, oxygen is gonna reach chemical stabilities. You count the number of dots over here: 1, 2, 3, 4, 5, 6, 7, 8. In the process, oxygen is gonna become a negative ion. And what is the oxidation number? Is gaining 1 and it's gaining 2, so it's gonna be negative to the oxidation number for oxygen. In that way, that's why oxygen is gonna be the anion, which is a negative ion. How are you gonna write the chemical formula? Since you have a positive 2 and a negative 2, you're gonna cancel, and the chemical formula for this compound is CaO. How are you gonna name an ionic compound? The cation, which is the calcium, doesn't change the name. So cation, calcium. The anion or negative ion, you need to drop the ending of the element name, and you need to add IDE. Okay, so the name of this ionic compound is calcium oxide. Here we have another example in which we're going to combine aluminum, which is a metal that is in group 13, and sulfur, which is a non-metal that is in group 16. Aluminum is in group 13 with 3 valence electrons. Since aluminum is the metal, aluminum is going to be losing the electrons to become a positive ion. Positive. How many electrons is going to lose? 3. 1, 2, 3. And you have the 3 over here. And the positive 3 is the oxidation number of aluminum. For sulfur, 1, 2, 3, 4, 5, 6. He needs 2 more. 2 more to reach 8. Since sulfur is the non-metal, the non-metal is always the negative ion. Sulfur needs 2 more to reach chemical stability, and that 2 is coming from there. Positive 3 for aluminum, negative 2 for sulfur. Those are the oxidation number for the metal and the non-metal. How are you going to write the chemical formula? Once that you have the symbol with the oxidation number for the metal and the non-metal, you're going to switch the numbers without the sign. Switch the numbers. Remember that we were doing that in class. You need to dance, baby, dance. You need to cross the numbers, and those are the numbers that are going to be at the bottom. Remember, those numbers, they are the subscripts. and the subscripts are the number of atoms that are involved in that compound. In this specific case, you have 2 atoms of aluminum and 3 atoms of sulfur. How you gonna name this ionic compound? The cation doesn't change the name. What is the name of the cation? Aluminum. The negative ion or anion, for the negative ion, you need to drop the element's name, the ending of the element's name, and then you need to add IDE. The name for this ionic compound is aluminum sulfide.